Question 17. Use Kirchhoff law rules to determine the value of unknown physical quantities shown in the electric circuit below. A battery, for sub-question A, a battery of electromotive force and internal resistance R is connected to the variable resistor of resistance R as shown in the figure. Here we have a variable resistor, resistance of variable resistor. Here we have internal resistance, electromotive force, and you have the current which is passing in the circuit. The resistance R of the variable resistance is varied. Iravaria, ino resistance R, here, as shown here. Then, ivaria with the variation of V with I is shown as is shown below. Here, this is the variation. This is the variation of V. This is the variation of current. This is the graph of V, the graph of V and the current, variation of V and the current. This is electromotive force. This is potential. Then here, for us, use the above figure to calculate the internal resistance. We are asked to calculate that internal resistance by using this graph. This internal resistance, it is equal to the minus the gradient on this graph, as the resistance ibingana na dufite V ibingana na IR, then R equal to V over I. Means gradient ya VI, it is equal to the resistance according to this figure. Then let's calculate the internal resistance using our graph. The gradient on this graph, you can find the gradient which is in the opposite direction. As you can see here, it is in the opposite direction because when it is in it should have minus. Let us see how the slope or the gradient is. The gradient is like this, then like this. As we can see, to calculate our gradient, we have the internal resistance. Here we have the current. The maximum current we have here, it is just in 1.5, and the minimum internal resistance is 0. Then we should have R, which is equal to, for potential, we have here we have 3, then 3, 2.9, 2. It is somewhere in 2.9. It is somewhere here. It is 2.8 on the graph. Then it will be equal to 2.8. Then the initial is somewhere here. It is around here. Is 198, 0.7. Then minus 0.7 because we should use change to calculate gradient. Then divided by here we have maximum. Maximum, it is not it is like 5, 6, 7. It is like here 1.6 minus the initial one. It is 0, minus 0, which will be equal to This should be equal to 2.1 over 1.6. Because, but here we may put minus because it is equal to gradient. R equal to minus gradient, which is equal to like this. Then you can calculate, then find the answer here, which is 1.4. For number E, calculate the resistance R. This is the resistance of the resistor. If the variable resistor is adjusted so that here V, electromotive force twari dufite, noneho yabaye dufite V potential ingana na 2.1 V. Here tuba dufite V which is equal to electromotive force minus I times Z minus I times Z R. Then we can find that R can be equal to electromotive force minus V over I. Then we find electromotive force, which is equal to electromotive force, which is equal to electromotive force equal to this electromotive force equal to 2.8 because it is the maximum potential the resistor variates. Then it will be equal to 2.8 minus then minus 2.1 millivolt divided by 1.4, which is the circuit, the IR, which is the R. Oh, sorry, this is IR. Then here we will find E minus E over R over. Then we find the R. R will be equal to we first find the V which will be equal to 28 minus I times the R. We first find V for internal resistance. Then we will get I, which will be equal to 2.1, which will be equal to 28 minus I R. This R equal to 1.4. Then this resistance for resistor equal to V over I. Then finding I will be equal to 2.1 minus 2.8 2.8 Yes, here is 2.8 over R. Then we will get I. Here we will get I, which is negative. This means that the circuit is moving in opposite direction with the electromotive force. Then we will get R here equal to 1.4. Then we find I equal to minus 0.7 over 1.4. Then after calculation, we can find resistance for our resistor, which will be equal to 2.1 divided by 0.7 over 1.4. We can calculate to obtain the answer of resistance. Then let's move with the next question. Number 17b, consider the diagram below of the electric circuit. We have electric circuit here. Here is the loop 1, here is the loop 2. Then, according to the loop 1, we should have algebraic equation. Starting from the current is from here, from this voltage, then it is equal to 20. Here, the V here, it is equal to resistance, which is 0.5 times I. The current which is passing in this resistance is I1. Then, because it is going in the opposite direction of the loop, we should have minus. Then, reaching to this resistance, also we are still having current 1 passing in this resistance. Then V will be equal to 0.5 times I1 also. Reaching here on B, we reach on the current 2. This current 2 is passing to this resistance, but still in the opposite direction with the direction of the rope. So we have also here minus 0.5 times I2, because the current which is passing in this resistance is I2. Then plus this voltage, this resistance, the current which is passing in this resistance is I2. Then the V will be equal to 0.5 times I2. Reaching here, the current which is passing, it is also I2. Then minus 1 I2. This should be equal to 0 according to Kirchhoff's law. Solving this equation, you should have, here it is minus, because this is the direction, here it is in the opposite direction of the loop. Then here we have I1, 1, 2. Minus 0.5 I2 minus 0.5 I2 without minus, we'll get minus 1 or minus I1 minus, here we have 2 I2, which should be equal to 0. Then we can get I1, which is equal to minus 2 I2. This is the first. We should have this. Then, considering it to the second loop, here we have, considering to the second loop, here we have the circuit is moving in the direction of, here we have the circuit which is moving in the direction of the loop. Then here we have 20, this 20, here the current we have here is 0.5, but it is in the direction of the loop, plus 0.5 I2. Then here the current which is passing in this resistance, it is I3, then plus 3I3, then reaching here, this voltage, it is in opposite direction with the direction of the loop. Then we have minus 6. Then the current which is passing is I3, then plus I3, 1 I3. Here, the current which is passing here in this resistance, it is I2, because this I2 is passing in this resistance, then pass here. Then minus, then plus 0.5 I2. This should be equal to 0 according to Kirchhoff's law. Then here we will have 40 plus I2 plus 4I3, which should be equal to 0. This is another, let's call this the first equation. Call this the first equation. This is the second equation. Then, according to Kirchhoff's law, this I2 is equal to I1 plus I3. This I2 equal to I1 plus I3. This is the third equation. Then, from here, we should get I3, which is equal to I3, which is equal to 14 plus I2 over 4. But this should have minus because we change the direction. It is out of this equal signal. Then here, from here, I2 is equal to minus I1 over 2. Then replacing the value of I2 here, we'll get I3, which is equal to minus 14 minus I1 over 2 divided by 4. Then I2, which is equal to I1 plus I3, we should have replaced by replace I3 by its value. We will have I2, which is equal to I1 plus minus 14 plus I1 over 2, then over 4. We have I2, which is equal to I1 this over 4 is only here. Yes. Then we have I2, which is equal to, here I1, here I1 is equal to, I1 is equal to minus, this I1 is equal to minus 2 I2, then plus I3, which is equal to minus 14 plus I1 over 2 over 4. Then calculating this, replacing I1 also here, the value of I1 by its value, here we have 2 I2, then 2 by 2, then we remain with I2 equal to minus 2 I2 minus 14 over 4 plus I2 over 4. Then we have I2 minus, this will have plus 2 I2 minus I2 over 4, which is equal to 14, here is 16, not 14, sorry. Here is 16. 16 because it is 20 minus 6. 20 minus 6. Okay, yes, it is 14. 20 minus 6, 14. Then we'll have this 20, this 14 over 4 equal 14. This minus 14 over 4. Those are 3. We have 3 I2 minus I2 over 4, which is equal to minus 14 over 4. Putting on the common denominator, we have 12, 4I2 minus 3 over 12, which is equal to minus 14 over 4. Then we have by 4I2 minus 3I2, which is equal to minus 14 times 12. By calculation, we'll find that this I2 will be equal to 2 minus 2 ampere, because here we have minus and here we have, this is greater than this one, then we have minus 2 ampere. Then we find that I1 is equal to minus 2 I2. Then I1 should be equal to minus 2 times minus 2 ampere, which will be equal to 4 ampere. Then I3 will be equal to I2 minus I1, which will be equal to I2 minus 2A minus 4A. This is equal to minus 8 ampere. Minus 2A. So I1 equal to minus I1 minus 2 I1 kuri current ya 1 here it is passing I1. This is I1. This is I1, I2, I1. Oh, 100 should say. Then here it is I2, then I1 will be equal to over I1, I2 over 2. I1 plus I3, I2 equal to I1 plus I3, then I1 equal to I2 divided by 2. I2 equal to I1, which is equal to minus I2 over 2 plus I3. I3, from here, I3 is equal to minus 14 minus I2 over 4. Then by calculation, we should have I2 plus I2 over 2, which is plus I2 over 4, which is equal to minus 14 over 4. Then by calculation, this I2 should be equal to minus 2 ampere. Putting I2 1 plus 1 over 2 plus 1 over 4 equal to minus over 4. By calculation, this I2 plus like this is equal to this I2. This I2 should be equal to 4 plus 1 over 4, which is equal to minus 14 over 4. Then we have we have I2, which is equal to minus 14 over 4, divided by, here we have 6 over 4, then multiply by 4 over 6, 4, 5, 6. Then I2, by calculation, I2 will equal to minus 2 ampere. Minus 2 ampere, as here there is minus. Then after finding I2, I1 is equal to minus I2 over 2. This means that I1 is equal to minus 2 ampere over 2. Over minus 2 ampere over minus 2 ampere. Then minus will be plus. Then we have I1, which is equal to 1 ampere. Then I2 equal to I1 plus I3. Then I3 will be equal to I2 minus I1, which will be equal to I2 is equal to minus 2 ampere minus I1, which is equal to 1 ampere, which will be equal to minus 3 ampere. As conclusion, those current for I2 is equal to minus 2 ampere, I1 is equal to 1 ampere, and I3 is equal to minus I3 is equal to minus 3 ampere.